Welcome. So today we want to discuss about definite integrals, indefinite integrals. So what are these? So recall a fundamental theorem of calculus basically gave us a connection between the it gave us the connection between the integral f of x dx from a to b with the antiderivative, namely this was f of b minus f of a. This was your fundamental theorem of calculus, where f is any antiderivative of f, right? So now there is a connection between the definite integral and the antiderivatives. So we want to connect, we want to exploit this relation further and see what do we get out of this. So recall, if you have a function f, if this is an antiderivative of the function f on interval I, then the most general antiderivative of f is given by f of x plus c. Why is that? Because if you take derivative of f of x plus c, then because of the definition of antiderivative, derivative of capital F of x is small f of x, and the constant c is derivative is 0. So if we look at it from the graphical perspective, so the graph of the family of f of x plus c are visually just vertical displacements. So these are just vertical displacements of f of x, right? Say, for example, if f of x was x squared, then f of x plus c is going to be same graph shifted. Say x squared is this here, x squared plus 2 is shifted up like that, and x squared minus 2 is shifted up like that. And this small f of x, which is a derivative of capital F of x, denotes the slope of these lines, and you see they are all equal at that point. So let's collect all the antiderivatives of a function and give it a name. So we get the concept of indefinite integral. So set of all antiderivatives of function f of x is indefinite integral of f of x with respect to x, and it's denoted by integral f of x dx. Now note that this definition is a consequence of, why do we have this notation can be thought of as coming from here, except that there are no limits of integration, right? So this is called, this notation, this expression here is called the indefinite integral. Again, when I have a symbol like this, we read it as integral of f of x with respect to x. And this symbol integral is called the integral sign. And the function which you are integrating is called an integrand function or integrand of the integral. And here the x, the variable x is called the variable of integration. So you're integrating with respect to x. Now the process of computing this integral would be called as, this process is called integration or integrating f of x. And also the above function definition says that if f of x is an antiderivative, then for some, or in fact for all antiderivative, all c, you have f of x, integral of f of x is capital F of x plus c. Yeah, unlike the definite integral, which came out to be function if the upper and lower limit are constant. So in this case, we had the definite integral was not a function; it was a value, right? A number. Whereas in indefinite integral, it's always a function. So this is the setup for indefinite integral. Now let's move ahead. Now let's again discuss there are common mistakes made while writing the integral. So one common mistake which is made is dropping the dx at the end of the integral. This is required because the integrand ends and tells you also what variable you are integrating with respect to. So yeah, we have to write here dx. Yeah, otherwise this does not make sense. So we need dx here. Now also forgetting, so if you forget the constant of integration, forgetting the plus c during the process thereby shows that the solution of indefinite integral process is, so if you do not write plus c, you are saying that it's not all the possible antiderivatives. So the answer is not, integration of x squared dx is not simply just x cubed, but it is x cubed plus by 3 plus c. Also, we have to be careful about quotients and multiples. We do not have the property to deal with products and quotients of function directly. All right, we'll come to some of them, like substitution and integration by parts, where we'll have a partial result. But clearly, this is not true. Integral of f of x d times g of x dx is integral of f of x integral of g of x. So this is not true. And similarly, integral of f of x divided by g of x is clearly not integral of f of x divided by integral of g of x. So these are not true by far. Okay. One can take an example and see this. So for example, y product is not true. Let's see. So take f of x equals to 1 equals to g of x. So LHS is going to be integral of 1 times 1 dx, which is going to be x plus c. And on the other side, we get what? Integral of 1 dx times 1 dx. And these two are not equal. Why is that? Because integral of this is going to be x plus c prime x plus c double prime. Here we have a quadratic, here we have a linear. So these two things cannot be equal, yeah, in general. So now these are the integral rules. So these rules must be already, these are the rules we are going to use when we are talking about integrals. So for example, you have integration of k dx, your k comes out, and integration of 1 is x, so we get plus c. Another rule is constant multiplication rule. If you have c times f of x, then this k times f of x, then the k can come out of the integral. You get k integral of f of x dx. Similarly, if you have f plus g of dx and you're integrating that, so integration of f plus g is same as integration of f plus integration of g. Power rule, log, we have already discussed. Exponential as well. So note that derivative of a to the power kx is a to the power kx times k times ln a plus c, of course. Sorry, not plus c, we're taking the derivative. So if you divide both sides by a to the k, so divide both sides by k ln a, you get a to the kx. So therefore, derivative of this is equal to a to the power kx, and hence the antiderivative is going to be this. Now these are the trig rules. Derivative of cosine is minus sine. Therefore, integral of sine is minus cosine. Integration of cos x dx is sine x. Derivative of tan x is secant square x. Therefore, integral of secant square x dx is tan x. And so on and so forth. Now note that derivative of, so arctan is same as tan inverse x. So derivative of tan x is 1 upon 1 plus x square. And hence antiderivative of, or the integral of dx upon 1 plus x square is arctan x. Arctan x is another way of, is basically another name for the same tan inverse x. Just an alternate notation. So these are the rules of integrals. Now let's use them to do some problems. So problem 1. We have 1 upon x plus e to the power x plus x to the power plus 7 dx. So now we can break, first of all, if I just write it like that, it's not correct, right? So we need to add a dx in the end, and then it makes sense. Without dx, it has no meaning. So we get what? We have integration of 1 by x dx plus integration of e to the x dx plus integration of x to the pi dx plus integration of 7 dx. Yeah, you can do it directly too. I'm just showing some steps here so that we have an idea of what's happening. So now integral of this is going to be 1 over x integral is absolute value of ln x. E to the power x integral of e to the x is e to the x. Now it is x to the pi, but pi is also a number. So this is a form x to the power n. So it's going to be x to the power pi plus 1 divided by pi plus 1. And the other one is integration of 7 is 7x plus a constant c. Yeah. Similarly, let's go for the next one. Integration of dt is 1 dt and integration of 1 is t, so t plus c. Again, plus c is important here, right? Now let's try to integrate this one here. Now this is same, can be seen as x plus 1 times square root of x. So we do not know any rules for product yet. So what we'll do is we'll open it and multiply it out. So this is going to be x square root of x plus square root of x dx. Now the goal is to apply the power rule. So let's write it as power. So this can be seen as x to the power 3 by 2 plus x to the power half dx. Now x to the power 3 over 2 can be seen as, if we want to integrate it, it's going to be x to the power 3 by 2 plus 1, which is 5 by 2, divided by 5 by 2, which is same as multiplying by 2 by 5. But let's leave it that. X to the power 3 by 2 divided by 3 by 2 plus c. All right, now let's move to the problem D. Again, we have one function divided by another. We do not have quotient rule. We do not have the rule of f of x divided by g of x. But in this case, we can simplify this, distribute x squared to all of them. So we get 4x to the power 6 minus 2x squared plus 1 by x squared dx. And the integral is going to be 4, constant comes out, x to the power 6 integral is x to the power 7 over 7 minus 2. Integration of x squared is x cubed by 3. And this is x to the power minus 2. And what is the integral of x to the power minus 2? X to the power minus 1 divided by minus 1 plus c. So this is how the integral is computed. All right, let's move on and compute few more integrals. But before that, notice the following. An equation, so what is a differential equation? So differential equation is an equation which has a derivative in it. Yeah, differential word comes from the, so differential equation, short is DE. So an equation involving derivative where we want to solve for original function is called differential equation. For example, dy by dx equals to x. So this is an equation which has derivative in it, and the goal would be perhaps to find y. So such an equation is called differential equation. Another example, f prime x equals to 2x is a differential equation with the general solution f of x equals to x squared plus c, as we have seen in the previous slide. Now let's look at the following. If f prime x is x to the 4 plus 2x minus 8x, find f of x. So you're given derivative, so we want to undo the derivative. So to undo the derivative, we have to have f prime x dx, that is going to be x to the 4 plus 2x minus 8 sine x. So I'm just writing the function as it is. Now we'll compute each one of them. So what is integral of x to the 4? So integral of x to the 4 is 4 plus 1, 5 over 5. Again, consequence of what? Consequence of power rule. Derivative of x square is 2x. So to integral of 2x is going to be x squared minus 8. Integral of sine x is minus cosine x. So we get plus 8 cosine x plus c. Yeah. So this is the solution to this equation. Now let's look at few more. So then the question is, how do we get x cubed square root of x squared minus 5? Now this doesn't, you cannot multiply it out and integrate. Similarly, what about integration of sine to the power 5x dx? Or for that matter, x, ln x. What about integration of x cube upon x minus 2x plus 2? Now these do not lie in the domain of basic functions or basic integration. For this, we will have new techniques. So clearly an antiderivative is not readily available. We have to do something more in this case. So we need to know integration techniques to be able to deal with above functions. Namely, we'll learn substitution rule, trigonometric power, integration by parts, partial fractions. So we need more methods which will come in the next part of this discussion on how to integrate slightly more complicated function. Now, most of the functions have no simple antiderivative, and we need approximation techniques to find so we need approximation to deal with those functions. Yeah, just because you have a function doesn't mean that you can always integrate it. Some functions you cannot write down the elementary antiderivative. All right, thank you.